Good afternoon, grade 12 learners. Welcome to Physical Sciences Chemistry lesson. My name is Thandwe Uwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center, and it is broadcast by Pagama Research and Development. Today's lesson, as you remember, is acids and bases, which is the continuation of what we did in our previous lesson. Now, before we're going to start with today's lesson, I want us to pay our focus to what we did previously, because it will assist us in order to understand what we are going to do today. In our previous lessons, we looked at different theories. We looked at Lorentz theory and Arena's principle. I just want us to recap on what we did previously in terms of definitions of the two theories or stating of the two theories. Let me start with Arena's, because I feel it is very important for us to know what does each principle say to us in order of acids and bases. When you think about Arena's principle said an acid is a substance that produces a hydrogen ion in a solution, and it forms a low concentration of hydrogen ion in water. Meaning that when an acid, according to Arena's, dissolve in water, what it will happen, it will definitely ionize. I hope you understand what do I mean by ionization in this lesson. As the acid ionizes, when the hydrogen ions are forming, the hydrogen ions concentration will be low, meaning that it will form the concentration of hydrogen ions. So therefore, it is very important to understand that if you are looking at acids, you know that there will be hydrogen ions that will be formed. Therefore, the hydrogen ions that will be formed according to the acid, they will depend on whether that acid is a weak acid or a strong acid. According to Arenas said a base is a substance that produces a hydroxide ion in water. And he further said a base, as the base is producing a hydroxide ion in water, it means that there will be hydroxide ions that will be formed after the base is producing those hydroxide ions. So what is important is you need to know how will a base dissolve in water or dissociate in water to form those hydroxide ions. Now, we even classified our acids and bases as strong and weak acids, as strong and weak bases. Now, what is very important is that immediately when you understand that an acid ionizes, you need to know how does an acid ionizes. We indicated that strong acids ionizes completely to form a high concentration of hydrogen ions. Weak acids ionizes incompletely to form a low concentration of hydrogen ions. We even further indicated that immediately when a strong acid ionizes, it means the concentration of the acid, which is a strong acid, is going to be equal to the concentration of the hydrogen ions that is going to be formed. However, if an acid is a weak acid, for the method that it ionizes partially, it means the concentration of the acid, which is a weak acid, might not be the same as the concentration of the hydrogen ions that are going to be formed. What will happen? As we know that as a weak acid ionizes, the concentration of the hydrogen ion will be lower as compared to the weak acid at its start before it ionizes. So it is very important to understand the two theories and also understand the definition of strong acid, weak acid, strong bases, and weak bases. Also, in terms of the bases, strong bases, we know that they dissociate completely. And we also indicated what do we mean by dissociate. It means that a base is already having the ions. As you pour it inside water, what is going to happen? The base will separate into its ion without forming new ions. So therefore, that is why we said in the previous lesson, we must know the difference between ionization and dissociation. Now, today, as we are going to start with our lesson, I also want you to remember the examples of strong acids and weak acids that we provided in our previous lessons, because they are going to make sure that when we are having a reaction, whether of an acid or of a base, we will know the expectations whether that acid will ionize completely or that acid will ionize incompletely. So it is very important that we recap from what we did in our previous lesson. Now, in today's lesson, we are going to look at, as we are continuing, we are going to look at the acid-base titration. Now, we are not going to do an experiment on acid-base titration. However, it is very important to know what are the requirements of you in terms of the examination, to know before you go for your examination, what is it that an examiner can expect from you in terms of acid-base titration. We are going to look at the we are going to motivate the choice of a specific indicator. I hope we did these indicators in our previous lesson. We talked about the choices that we have to make when we are having an acid-base reaction whereby a neutralization reaction takes place. So we indicated that we have 3 types of indicators that we are going to choose from, which are stipulated according to our exam guideline. We have a methyl orange, we have a phenolphthalein, and a bromothymol blue. And we even indicated where is methyl orange suitable, where is bromothymol blue suitable, and where also phenolphthalein is suitable. So it is very important that when you are going to do your acid-base titration, you also know which indicator will be suitable for your reaction. However, that cannot happen if you don't remember or if you don't recall the type of acids that we dealt with in terms of classifying them as strong or weak acid, and also in terms of the bases as strong or weak bases, because the choice of the indicator will always depend on whether what type of an acid and a base are reacting at that particular reaction. We are also going to look at the definitions. As I said, we are going to define an equivalence point, which is the point at which the acid and base has completely reacted with each other. Therefore, it means at the point where the acid and the base has reacted with each other, we say that point is an equivalence point. And then we are going to look also at the end point. What do we mean by end point of titration? End point of titration is the point where the indicator changes the color. Remember, the indicators that we are referring to here are the indicators that we are going to use as we are going to choose them, looking at the suitability of the indicators in terms of the acid and the base that are reacting. Therefore, if that indicator changes color, is when now we have reached the end point. And when the acid and the base have completely reacted with each other, we say we have reached the equivalence point. So we need to know the difference between what do we mean by equivalence point and also what do we mean by the end point. We are also going to perform some stoichiometric calculations based on titration of strong acids and weak acids and strong acids and bases, strong acid and weak bases, and weak acid and strong bases. As we did in our previous lesson where we were doing hydrolysis, we never looked at the reaction between weak acids and weak bases, but we're always looking at weak acids, strong bases, or weak bases, strong acids, or strong bases and strong acids. So we are going to look at those stoichiometric calculations in terms of the strength of the acids and bases. There are some calculations that might also include percentage purity. We know that when we talk about percentage purity is when we are looking at the percentage of how pure are the reactants that are reacting. So it's in terms of the reactants. Whereas when you look at the percentage yield, which is not stipulated on our exam guideline, we look at the yield of the percentage of the product that is formed in that reaction. So purity has everything to do with the reacting substances, which are reactants. And then for titration, the titration that you are expected to understand and to perform is the titration between oxalic acid and sodium hydroxide. Immediately when you look at the titration between oxalic acid and sodium hydroxide, the first thing that must come into your mind, you must ask yourself, what type of an indicator must I choose for me to undergo the titration between oxalic acid and sodium hydroxide? What do we know about oxalic acid? We know that oxalic acid is our weak acid. And we also know that our sodium hydroxide is our strong base. Therefore, in terms of choosing the indicator, we need to choose an indicator that will allow a basic solution, that will allow whereby a base is reacting with a strong acid, and the pH, of course, it will be greater than 7. So you know that as we dealt with the different types of strength of acids, and how do we choose their indicators because of the different pH that they will produce after the solution, we have to know what type of an indicator we have to use in that reaction so that we can reach our endpoint. We also have to interpret the results to determine the unknown concentration. This is the continuation of our calculations of concentration that we did from our grade 11 class. Now, we are also going to look at the pH and the pH scale. We already talked about pH and the pH scale in our previous lesson. However, this time we are going to look at how do we calculate pH and how do we calculate the pH of strong acids and strong bases only. Because when we are going to look at the pH, we are only going to concentrate on the pH of strong acids and strong bases. I said, where you have a weak acid or a weak base, an examiner will definitely provide you with a pH so that you calculate some of the variables. However, if you need to calculate a pH, you need to calculate the pH of strong acids and strong bases. What is the reason for that? We already know that strong acids and strong bases, strong acids, they ionize completely. Therefore, it is easy for you to know the concentration of hydronium ions of a strong acid, because you know that after in a strong acid like hydrochloric acid, if I can give an example, a strong acid like hydrochloric acid, if it ionizes, it will form H plus and Cl minus. So already you know that if you know the concentration of this acid, you already know the concentration of the hydrogen ion or the hydronium ions. So it is very important that always when you look at the calculations, you look at the concentration of that specific acid, and you will know that the ratio in which the acid and those hydronium ions are going to react, it will also be taken into cognizance. For example, if I'm making sulfuric acid to react or to ionize, it means I will form 2H plus Cl minus. So you can see that now, instead of 1:1 ratio of hydrochloric acid with hydrogen ion, in case of sulfuric acid, the ratio is going to be 1:2 hydrogen ions. So it is very important to remember that as I was defining the strong acids and strong bases, as I was defining the Arenas and Laurie-Prostit theories, those principles are the ones that are always going to be used when we are explaining some of the concepts that we are going to deal with today. And then we are going to define the Kw, which is the constant for ionization of water, or the ion product of water, or the ionization constant of water, which is going to be defined as Kw, which is represent the constant ionization of water, which is equal to the concentration of hydrogen ions multiplied by the concentration of hydroxide ions. And Kw is provided a constant which is 1 to the exponent negative 14. So it is very important that you know the Kw value, because some of the instances you will find that you are looking for the concentration of a base, and you know that a concentration of a strong base is nicely classified or is nicely defined by the concentration of hydroxide ions, because when a strong base also dissociates, the concentration of that strong base will be the same as the concentration of the hydroxide ions that will be formed during that reaction. Now, the Ka value I also explained, and the Kb value I also explained in our previous lesson. I also indicated that in some instances, the examiner can give you a Ka or a Kb value in case where now you don't classify or you don't know whether that acid that you are provided is strong or weak. So I said to you, when the Ka value is greater than 1, we know that it represents that is a strong acid. And when a Kb value is greater than 1, it indicates that it's a strong, this one is a strong acid, because the Ka value is greater than 1. Kb indicates that this one is a strong base. So it is very important that always when you are provided a Ka and the Kb value, you know that the information that the examiner is trying to provide to you, it is trying to give you the strength of that acid or that base. So it is very important that you always know, or you always check the numbers that you are provided without being confused, especially when you are provided the exponential in exponential form or in case of decimals. As long as you know the numbers in terms of how do you express them decimally, from decimal to exponents or from exponent to decimals, I don't think you will have a problem in terms of understanding whether the Ka value is greater or the Ka value is smaller, or whether the Kb value is greater or smaller. We are also going to look at, we are going to compare the strong acid and weak acid, looking at the pH. We need to understand that if you are having a pH scale, you need to be able to classify in your pH scale where are you reading the pH of the strong acids, and where are you reading the pH of the weak acids. So most of the time you'll find that the strong acids, in terms of the pH, they will have a pH which is less, maybe pH of 0, something, or 1 or 2, which shows that they are ionizing completely and their pH is low. So the low pH indicates that that acid is a strong acid. And then you will also know that if you have pH like 3, 4, 5, which is your pH, you will know that now you are representing weak acids. However, always you will be understanding that if you are given data, you will be able to classify that data as whether that specific strength of an acid or the pH of an acid is a weak acid or a strong acid. In terms of conductivity, I think we need to explain what can we say about weak acids and strong acids in terms of their conductivity. We will know that as weak acids ionizes incompletely, we know that as they ionize incompletely, therefore it means that they will produce a low concentration of hydronium ion. For the method that they produce a low concentration of hydronium ion, in terms of conductivity, in terms of electric conductivity, they will also have a low conductivity as compared to strong acids. Strong acids, because they are ionizing completely and they produce also a high concentration of hydronium or hydrogen ions, they will definitely have a high conductivity as compared to the weak acids. And as they have a high conductivity, it shows that even the rate of reaction of strong acids will be faster as compared to the rate of weak acids. So the examiner wanted us to only relate or compare the strength of the pH, of the conductivity, and the rate of reaction in terms of the weak acids and the strong acids. So the strong acids, because of ionizing completely, they will have a low pH, they will also have a high conductivity, and also they will have a high reaction rate as compared to the weak acids. This is the table that I was referring to, and we also used it in our previous lesson, whereby we're choosing suitable indicators. So you know now that as we are going to use an oxalic acid, which is our weak acid, and we are going to use a strong base, which is sodium hydroxide. So you look where you have a weak acid and a strong base. Therefore, for the reaction or for the titration of oxalic acid and sodium hydroxide, definitely we are going to use what? Phenolphthalein indicator, because it's the one that is having a pH which is greater than 7, which shows a basic solution. So the reason why I said you must definitely know the strength of an acid and the strength of a base that are reacting before you can choose a suitable indicator. And for the method that that suitable indicator is been chosen is because of the pH that indicator is given or is giving after the acid has reacted with the base. So we know that the salt that will be formed will be a basic salt. And we also explain in terms of hydrolysis to say how do we see that is a basic salt. We see that is a basic salt by producing, when you make that salt to react with water during hydrolysis, which is the reaction of salt on water. When you make hydrolysis, whenever you find an OH minus as one of the products formed, you know that salt is basic salt. When you find H3O plus formed, you know that salt is acidic salt. So always when you want to check whether a salt is a basic salt or an acidic salt, you will just make that salt to react with that salt to react with water. When that salt react with water, when OH minus are being part of the products that are formed, you will know that that salt is basic. And when the H2O plus are being formed, you will know that that salt is acidic. For us to be able to do the stoichiometric calculations, I think it is very important that you also go back and do some revision on how do we calculate the number of moles, the volumes, even though we are not going to do all the activities because of time, but just to recap, because we are going to start now and use this information. So we need to definitely remember such information. So for us to start calculations or to start with stoichiometric calculations, we definitely need to have our periodic table next to us. Why do we need periodic table next to us? Remember, for many calculations that we'll be doing, we'll be referring to the atomic mass of the atoms, and that will give us our atomic mole or atomic molecular masses. So it is very important that your periodic table is always handy. As I always said, that when we are doing chemistry, we will always need our periodic table next to us. Now, let's look at the first example. We are not going to do all the examples, but I just want you to remember some of these important facts about how do we calculate the number of moles with the data that we are provided. When you look at the first example that we have here, calculate the number of moles in 96 grams of sulfur. Now, we are going to use this formula because the example that we are using, it will allow us to use the given formula for us to be able to calculate the number of moles. Because this is not the only formula that we are going to use to calculate the number of moles. So I will try to remind you all the formulas that we use to calculate the number of moles. In this instant, we know that we are looking for the number of moles. So as we know that the number of moles is equals to N is equals to mass over molar mass. Therefore, we know that we don't know the number of moles, but what do we know? We know the mass. So it's going to be 96 grams divided by what is the molecular mass of sulfur. So what you're going to do, you're going to atomic mass. You're going to look at the periodic table and look at the atomic mass of sulfur. And we know that sulfur is element number 16 and its atomic number mass is approximately 32. So you'll say 96 divided by 32. And when you say 96 divided by 32, you'll find that the number of moles that you are going to get for this is going to be, number of moles is going to be 3 moles. If I'm not mistaken, because 2 into is going to 3 times. So it's going to be 3 moles of this. So you need to remember this because you are going to use this information. In our second example, they've given you the number of moles. Now they want you to calculate the mass. In this instant, when they've given you the number of moles and want you to calculate the mass, you can just say, we know that number of moles is equals to mass divided by molar mass. You can use a capital letter. And we were provided 0.5 moles. And then the 0.5 moles that were provided, they were for, let me just go back, they were for sulfuric acid. Now, what is important is that now, you don't know the mass because it's what they are looking for, but you also need to know the molar mass. So how do we find the molar mass of sulfuric acid? Sulfuric acid is H2SO4, just to remind you. How many, in terms of the hydrogen, atomic mass of hydrogen is 1, but there are 2 hydrogens. So it's 1 plus sulfur, we said is 16, and then plus 6, we said is 32 sulfur, and then 16 times 4 for oxygen. Then I think it's going to be 98 grams per mole, which is the 98 grams per mole, which is the molar mass of what? Which is the molar mass of sulfuric acid. Immediately when you, after getting the molar mass of sulfuric acid, you're just going to substitute on our molecular formula. I don't encourage you to change the subject of the formula, which is going to be here. We're going to put 98 and then we cross multiply, and when we find our mass. I will never encourage you to change or to make a mass the subject of the formula. Just use the mass according to the data sheet or the mass that you are provided in your examination, so that you just substitute direct in that equation for you to get the number of moles. Let's go to another equation that we can use to calculate the number of moles. We know that we can also calculate the number of moles using the atoms and the Avogadro's number. The Avogadro's number is provided to you in your data sheet where you are given the constant, and the value of the Avogadro's number is 6.02 times 10 to the exponent 23, which is a very huge number. Therefore, you know that if you need to calculate the number of atoms, or if you need to calculate the number of moles, you need to be able to use this formula for you to calculate the number of moles. In this case, they say how many atoms are there in 4 moles of magnesium. Therefore, we know that in 4 moles of magnesium, you are given the number of moles, you know the Avogadro's number, and then you know you can find the number of atoms. Then, after finding the number of atoms, dividing by this number, you will be able to find how many moles are there in 0.4 in 4 moles of magnesium. So this is one of the formula that we can also use to calculate the number of moles. The last one is the one that we are using, the molar volume. Remember, this is also a constant at STP, which is 22.4, is provided to you at STP, standard temperature pressure. For you to qualify to use this molecular, to use this specific formula, you need to always know that that specific gas that you are calculating the number of moles of, it is at STP. This cannot be used if the condition is not saying standard temperature and pressure. Like when you look at the first example, because I think this is a confusion to many of the questions or of many of the equations that we normally see in terms of calculating the number of moles, where we have CV, which is the concentration, and the volume. Normally, we will see learners substituting this volume as a normal volume without being told that this specific reaction occurred at standard temperature pressure. So you need to know that you can only use this formula when you know that the reaction is under, or the condition of that reaction are under the standard temperature and pressure. So like in this one, because the constant is not provided to you, they say calculate the volume occupied by 0.5 moles, and it's for the gases. You must know that we are going to use it at STP. What we are going to calculate the number of moles using this formula, we are going to use it for the gases. So when you look at this one, is N is equals to V over Vm, and then the number of moles is 0.5, and then we want the volume. We don't know what is the volume, but we know that at STP each gas occupy a space of 22.4, which is provided on your data sheet, and then you cross multiply and find the volume that is occupied by that gas in decimeter cube. Remember, always when you do calculations, we must make sure that we write the correct formula units for that specific calculation or for that specific answer. Where the units are not required, we need not to put the units, because if you put the units where they are not required, it means your answer will be incorrect. So you must make sure that always when you need units, you are needed to put units, you must definitely put those units. These are other examples that we can use, but definitely we cannot be able to use them here. Like this one, we are given not the number of moles, but we are given the mass of oxygen at STP. So you know that from the mass and the molar mass, we can be able to find the number of moles. And then after finding the number of moles, you are going to use this formula for you to be able to calculate the number of moles at STP. So this is I'm just trying to give you some background of what you did in our grade 10 and our grade 11 classes, so that you remember how do we calculate number of moles in different formulas, and what were the conditions for those formulas to be used when we're calculating the number of moles. Okay. I just chose this just to say we can look at them. This one is giving you the volume at STP, and it say calculate the mass. So you know that if you are given the volume, and you know that the number of moles, the formula says N is equals to, let me just remove this, it's equals to V over Vm. So here you are given the volume, but they are looking for the mass. So where do we get the mass? We know we get the mass from N is equals to M over M. So the first thing that we need to do, we need to calculate the number of moles first, so that we can have this formula that will assist us to calculate mass. Therefore, we are going to say here the volume is 40, and then we know that here is 22.4, and then it's N. And then we are going to get our number of moles in mole, which I'm not going to do for you. You can do it with your calculator. And then after getting those number of moles, you're going to substitute them here. You are already given the formula of carbon monoxide SCO. Then you can find the molar mass and find the mass, because the number of moles are going to be determined after you have used the molar volume formula to calculate the number of moles. So these calculations, they are you know, if you don't know where they start or their starting point, it might be very difficult to do the complex stuff, whereby now you'll be given too much information and you still need to use these basics for you to be able to calculate those stoichiometric calculations. This one is the one that we are going to use mostly, because they said we need to be able to calculate the concentration of an unknown acid or an unknown base during our titration. So this is going to be one of the formulas as that one of the number of moles that we are going to use more often in our calculations, because we'll be definitely looking for the concentration of the unknown acid or an unknown base. Now, we know that in grade 11, when we calculated concentration, we know that concentration is number of moles divided by the volume. And we know that in some instances, they were providing us this concentration of a solution. And we were always told that if you know the concentration of a specific solution and you want to use it to find the concentration of another solution, the concentration of a known solution is referred to as standard solution. What is a standard solution? A standard solution is a solution of a known concentration. So if you know the concentration, standard solution is a solution of a known concentration. Therefore, if you are given a specific acid or a specific base and they are telling you the concentration of that acid or a base, already you are provided with a standard solution. So it means you can use a titration method or the volumetric method for you to be able to find the concentration of the unknown substance. So I'm just reminding you to say, remember, we also talked about standard solution in our previous lesson or in our previous grade, where we said a standard solution is a solution of a known concentration. Like, for example, let's look at this example here. We are given the calculation. They say calculate the concentration of 10 cubic decimeter solution that contains 0.6 mole of hydrochloric acid. The first thing we need to remember, the units of concentration, mole per decimeter cube. Therefore, you must make sure that always your volume is provided in cubic decimeters, because if it is not provided in cubic decimeters, you are not going to be able to calculate the correct concentration with the correct units. So always when you are provided cubic centimeters, you know that when you are provided cubic centimeters, you divide by 1,000 for you to get cubic decimeters. So always convert, because conversion is one of the skills that we have learned, so that when the units that we are provided are not according to the required units, we will always convert back or convert forward, so that we find the required units and be able to make sure that we write the correct units. So here you have a volume, you have the number of moles. You just use this a simple formula that says C is equals to N over V, whereby you are going to use what? Number of moles is 0.6, volume is 10, and then you calculate the concentration, and you are going to get X of the concentration in mole per decimeter cubed. The reason why I don't want to give you all these answers is because you need to also be able to calculate these answers using your calculator. So a calculation using a calculator is also another skill that you must make sure that you acquire before you go for your examination. And another advice that I can provide to you is that when you are using a specific calculator, make sure that you always use that calculator so that you get used to it, and also know all its operating buttons, so that you don't make mistakes in terms of calculations when you're looking for the answers. But these are just simple calculations where you are using your calculators, you can be able to find them. And then sometimes you can be provided with the number of moles with a volume like this one. You know that here we just have to divide by 1,000. However, we're going to use the same method. And then when you are provided the mass and the molar mass, already the examiner is providing you with the number of moles. So you can use this information to find the number of moles, so that you can be able to substitute it in our equation. Okay. Now, as I said, we are going to calculate pH. The pH that we are going to calculate, as I said, is going to be the pH of strong acids and strong bases. The reason is because they ionize completely as strong acids and dissociate completely as strong bases. What do we use to calculate pH? pH is provided as the pH is equals to negative log concentration of hydrogen ions, or we can say concentration of hydrogen ions, where hydrogen ions are formed when hydrogen ion react with water. So this is a formula that we know that our log is always base 10. So this is the time where we are going to use our mathematics information, where we are going to look most of the time to use anti-log to find the pH, or sometimes to find the concentration of the hydrogen ions. So it is very important that you just go back and think about how were you using the anti-log, changing from exponent to logs and changing from logs to exponent of base 10. So here you are provided that there is always a negative sign. Don't forget this negative sign. And for you to write this formula incorrectly, you are not going to be given any mark, because you just copy this formula directly from your data sheet. So it is very important that when you are copying a formula directly from your data sheet, you write the correct formula, because you are just looking and just transferring to your answer book. So if this minus is not there, therefore your formula is incorrect. Even if this 10 is not there, because most of the time we don't include it, because it's log 10 to base is 1. So it's going to be, we normally say minus log the concentration of H3O plus, or the concentration of H plus, which is the pH, capital letter H, small letter P, the way it is written here. So we normally don't even worry if you don't put this 10, but this 10 we just put it so that when you are working with anti-log, you know that everything is base 10. That is why you need to have that information. Let's look at this example in terms of the calculation of the pH. Now we remember that When you calculate pH, pH is equals to negative log the concentration of H3O plus ions. Where do we find H2O plus ions? The principles that we've discussed, they've assisted us to say when acids ionizes, and especially when they ionize in water, the hydrogen ion of an acid that is produced is going to quickly combine with water and form a hydrogen ion. So therefore, we know that H plus and H3O plus, they are coming from an acid. Therefore, it is very easy when you know the concentration of an acid, which is a strong acid. You will already know that the concentration of a strong acid will be equals to the concentration of the hydrogen ion. This is I just want to put a disclaimer to say, not always when you have an acid, you will think that the concentration of that acid is equals to the concentration of the hydrogen ions. The first thing that you have to establish is that whether that acid is a strong acid or a weak acid first, before you can relate the concentration of the hydrogen ions. So for this example, we are provided a concentration of hydrochloric acid. So the first thing that you need to understand is that, do you know that what type or the strength of hydrochloric acid? And we know that hydrochloric acid, as we classified it in our previous lesson, and also as it is stipulated on our exam guideline, we know that this is a strong acid. Therefore, if hydrochloric acid is a strong acid, when it ionizes as HCl and H plus plus Cl minus. Therefore, if I know that the concentration of hydrochloric acid is 0.1 mole per decimeter cube, it is obvious, because it ionizes completely, that the concentration of this hydrogen ion is also 0.1 moles per decimeter cube. Therefore, I will just take the concentration of an acid. I will make sure that I use pH is equals to minus log the concentration of hydrogen ions, and therefore I'd say minus log, and then immediately when I substitute the concentration, which is 0.1, I just use the round brackets, and this pH is going to be 1. Remember, there are no units for pH. So you need to establish first whether the acid is a strong acid or a strong base. That acid is a strong acid or the base is a strong base, before you can conclude in terms of the ions that are going to be formed, in terms of the relationship between the ions and the concentration of that acid and a base. Making sure that if you're not sure, you must know that that acid ionizes completely or incompletely, or whether that base dissociates completely or incompletely, before you can quickly just substitute, as I did in my first example. Okay, let me just go back quickly. So what the explanation is that when the hydrochloric acid reacts with water, 1 mole of hydrogen ion is equals to 1 mole of and 1 mole of chloride ion, and the 1 mole of hydrogen chloride is also equals to the 1 mole of hydrogen, where is it, hydrogen ions. So that is why it was easy for us to quickly just put or substitute the 0.1 of hydrochloric acid in our hydrogen chloride. Now, when you calculate a pH of a strong base, it is going to be a different story, because remember, a base doesn't produce a hydrogen ion or a hydrogen ion, but it produces what? Hydroxide ions. So as bases produces hydroxide ions, it is not easy just to use these hydroxide ions concentration to substitute them in the hydrogen ions concentration as according to the pH formula. You need to firstly be able to figure out the hydroxide ions before you can find the hydrogen ions, and therefore use the pH formula. So as we were busy with the introduction, we talked about the constant ionization of water, whereby we know that the constant ionization of water will give you both the hydrogen ions and the hydroxide ions. As water dissociates, we know it forms H plus plus OH minus. So we can say H plus or AOS, H3O plus, it is still the same, and OH minus. So this is the product of the ions of water that is provided by Kw. And Kw, as I said, it is provided 1 times 10 to the exponent minus 14, which has a lot of units on it as the constant. So Where can I find hydroxide ions? I can find hydroxide ions here, and I can find also hydrogen ions here. So it is easy for me. If I know hydroxide ions, I can be able to find the hydrogen ions by using the Kw formula. So when we calculate the pH of the bases, the constant ionization of water will be very handy for you to use in order for you to be able to find the hydrogen ions. Let's look at this example. This is what I was just trying to explain. So the method is that for you to calculate the pH of a strong base, make sure that you firstly wake up the concentration of the hydroxide ions, and then use the Kw to wake up the hydrogen ions or the hydrogen ions concentration, and then convert the hydrogen ions into the pH, and therefore you'll be able to find the concentration of a base. Now, we are just going to look at the following. Let me just go straight to the question. Here it says calculate the pH of 0.5 mole per decimeter cube of a base, which is sodium hydroxide solution. Now we are given the concentration of sodium hydroxide solution. Therefore, we know that if we know the concentration of sodium hydroxide solution, we know that sodium hydroxide dissociate as NaOH, providing us Na plus OH minus. Therefore, if we are provided 0.5 moles per decimeter cube of sodium hydroxide, we already know the number of moles of, not the number, the concentration of hydroxide ions, because sodium hydroxide dissociates completely. That is the main reason we are relating the two concentrations. Because it dissociates completely, it means its concentration will be the same as the concentration of the hydroxide ions. Therefore, now if we are looking for the pH of sodium hydroxide, we already know the concentration of hydroxide ions. We can use the constant ionization of water, whereby we are going to substitute the hydroxide ions and find the pH of, not the pH, the concentration of hydrogen ions. After finding the concentration of hydrogen ions, we are now going to be able to use pH is equals to minus log concentration of H3O plus. And then, because we have already found the concentration in mole per decimeter cube here, just forgot to put the units, we can easily go and say minus log the concentration of the pH I think it was 0, something, and then this one, and then we substitute with the pH that we're gonna get here of an acid, and our answer, I think I just went to the answer because I want you to find the answer after using the logs, and the answer is 13.7. Now, if you look at the pH, which is 13.7, the first thing that you must ask yourself is sodium hydroxide acidic or basic? If the pH is greater than 7, we know that is basic. So we know already by calculating the pH of sodium hydroxide that sodium hydroxide is a basic substance, it's a base, and it's a strong base because of 13.7. Remember, pH ranges from 0 to 14. So 13.7 is somewhere here, which is an indication of strong base. So sodium hydroxide is a strong base because it's having a very high value of pH, as we are using the pH formula to calculate is a formula. So sometimes the examiner can provide you with what? Can provide you with the pH, and you need to calculate the concentration. So we can even manipulate this pH formula by checking whether you need a concentration of hydrogen ions or you need the concentration of the pH. The pH. So this one is the one that we're using for the acid, whereby we're calculating the acid, and this one, when we are, this one is just an example where we are given the concentration of hydrogen ions, and then we can calculate and find the pH, and this pH is 6, showing that this acid is a weak acid. And then when we are provided hydroxide ions, we have used the Kw here because we're given the concentration of hydroxide ions, as we're looking for the concentration of H plus ions, and then we substituted and we find that the pH is 12.2, which also indicate that this one was also not as weak but not as strong base. So it's almost 13, so I can say it's a strong base. So these are some of the examples that you can see and remember when we are calculating pH of strong acids and strong base. So what I'm going to do now, I just want to do this activity. I will give you 3 minutes because we don't have enough time. Our time is so limited today because we need to cover some of the activities so that you can see how do we answer these questions. So I'm saying here, calculate the pH of sulfuric acid solution of concentration 0.6 moles per decimeter cube. And you are provided the reaction of sulfuric acid when it reacts with water. So I'm saying the pH that I'm expecting you to get is this one. So you are going to use this calculation and the information that I just provided to you in 3 minutes to calculate the pH of sulfuric acid. So our 3 minutes start now. Welcome back, grade 12s. I hope you have enjoyed the question that was posed to you, and I also hope that you will manage to get the answer that was provided to you. Before we go to the question, I am having a question from our WhatsApp line. There's a learner, even though the learner didn't explain where he or she is coming from, I will always like to see where you are coming from. Just write on your WhatsApp, you indicate the name of the school where you are coming from, and you ask a question so that we know who are we definitely talking to. Now, the question was asking about, ma'am, how do I see whether this is a strong acid or a strong base? I started by explaining in our previous lesson that some of the strong acids and the strong bases were provided to you on your exam guideline. The example of the strong acids that were provided to you were hydrochloric acid, sulfuric acid, and nitric acid. And then the strong bases were sodium hydroxide, lithium hydroxide, and potassium hydroxide, meaning that the metal hydroxides, in terms of the bases, they are strong bases. However, more than that, the examiner can give you a clue for you to be able to know whether you are dealing with a strong acid or a strong base. An examiner will give what we call Ka value. Let me just use this slide. The constant ionization of that acid or constant ionization of a base. Therefore, in simple terms, if a constant ionization of an acid is provided to you and they're telling you that is less than 1, or the number that you are provided to you is less than 1, you will know that it's a weak acid. However, if the Ka value is greater than 1, you will know that it's a strong acid. That is what I explained previously. And if the Kb, because it's a constant ionization of a base, if it is greater than 1, you will know that that base is given to you as a strong base. So this is some of the information that an examiner can provide to you by giving you a clue whether the acid that you are provided is strong or weak, especially if that acid is not a common acid, or if that base is not a common base. You can just use Ka and Kb values to determine that specific acid and base. I hope definitely you are answered from the explanation that I've provided. If the explanation is not quite enough, you can also be assisted by your teacher at your school so that you can understand what you mean by Ka value and Kb value, because we already did equilibrium constant, and we know that. How do we calculate equilibrium constant? We calculate equilibrium constant by saying is the concentration of the product over the concentration of the reactants. So if the Ka value is greater than 1, it means there are still more of the is less than 1. There are still more of the products than the reactants. Therefore, it shows that it means the ionization is incompletely or the ionization is completely. So if the ionization is completely, you will see by making sure that the constant ionization is greater than 1. And if the ionization is incompletely, the Ka value will be less than 1. Just like that in terms of the bases, in terms of the dissociation of bases. Now let's go back to our question. We are provided with the sulfuric acid reacts with water to produce 2 hydronium ion and sulfate ions. Now the first thing I think that you did, you know that we are required to calculate the pH, and we are provided the solution, the concentration of the solution of sulfuric acid. So we know that sulfuric acid, as it dissociates H2SO4, dissociates to form what? 2H plus SO4 2 minus. Immediately when you have this, you already know now that the ratio of the reacting of an acid and the ions is 1:2. So for every 1 mole of sulfuric acid, we are producing 2 moles of hydrogen ion. That was the only trick about this question, because now we are having a diprotic acid. I remember last time I explained what do you mean by diprotic acid, which is an acid that can be able to donate 2 protons, and a monoprotic acid, which is an acid that can donate 1 proton. So because here we are having diprotic acid, it means there are 2 protons, meaning that if now we have to talk about the pH, it means our pH is going to be minus log and then concentration of 2 hydrogen ions, meaning it's going to be pH, which is equal to minus log, then it means it's going to be now 2 times 0.6 mole per decimeter cube. We are aware that sulfuric acid is a strong acid and it can ionize completely. So meaning that each of the hydrogen ions that is going to produce by the sulfuric acid, they will each have 0.6 mole per decimeter cube. So therefore, that is why we multiply by 2, so that we show that there are 2 of these hydrogen ions that are formed, and you will definitely get your pH as 0.8. If the pH is not 0.8, just check your calculator and see what might be the mistake on your calculator. But the issue here, the reason why I gave this activity and I wanted you to do it, is because now I'm dealing with a different type of an acid, which is a diprotic. If it was a triprotic acid, it means it was going to produce 3. So now, because it's diprotic acid and is the only, because we are only going to look at monoprotic and diprotic acids only in terms of the type of acid, classifying them in terms of proteolysis or in terms of the protons that each acid can produce. Let's look now at this exam previous paper. When you look at this exam previous paper, I will try by all means and make sure that some of the things that were not clarified or were not well clarified, they are clarified, because most of the time the questions are assisting us to get the clarity in most of the things that we are learning about. So assessment it plays an integral part of learning, because it will show you whether you understand or you don't understand a specific topic or content. We are having sulfuric acid, which is provided formula H2SO4, and we are told that it ionizes into 2 steps. I told you previously that most of the diprotic acids, they will ionize in 2 steps, because they will provide the first proton and also be able to provide the second proton. So as sulfuric acid is ionizing in 2 steps, it is also an indication that is a diprotic acid. So sulfuric acid, the first reaction, we have sulfuric acid reacting with water to produce a hydrogen sulfate ion and hydronum ion, and the examiner provide you with a Ka value. As I said with the previous question that Elena asked, I said where it is very important that you need to understand which one is a strong acid or which one is a weak acid, the examiner will provide you with the Ka value or the Kb value. So we know that 1 times 10 to exponent 3 is the same as 1000. It's fine. So the Ka value here is 1 times 10 to exponent 3. For the second reaction, the hydrogen sulfate ion reacted with water again and formed a sulfate ion and hydronum ion. So these are 2 ways in which sulfuric acid ionized in water. The first step, it produced hydrogen sulfate ion, and that hydrogen sulfate ion also reacted again to produce a sulfate ion. So it is very, very important that you remember what we did previously, so that you can link this reaction with our previous lesson. And the Ka value here is provided as 1 times 10 to exponent -2, which is the same as 0.02. So immediately you need to ask yourself these Ka values. Does this indicate weak or strong acid? Does this indicate if you compare the 2 Ka values? Because the examiner is trying to provide you a clue to say which one is a strong acid between the 2 acids that are reacting in reaction 1 and in reaction 2. Let us identify those acids. We are going to identify the acid in reaction 1 and in reaction 2 by using the principle of Lorentz or the Arrhenius principle, so that we can see whether we can be able to identify those acids. And if we can be able to identify the acids in the 2 reactions, we can also be able to identify the bases, and we can also be able to identify the acid-base conjugate pairs, because that is the relationship that you need to understand immediately when an acid reacts or immediately when an acid ionizes. When you look at sulfuric acid is a strong acid, we already know, and we can also look at the Ka value, which is greater than 1. So sulfuric acid will do what? Will donate a proton to water. So it means here sulfuric acid is an acid, and water here is our base. And then after sulfuric acid donating a proton, according to Lorentz theory, as sulfuric acid is our proton donor, this sulfuric acid will produce this conjugate base, which is H2SO4. So this one is an acid, and this is a conjugate base of this acid. Therefore, and then water will combine with, will accept the hydrogen or the proton from sulfuric acid and form a hydronium ion. So our acid here, we have an acid, which is sulfuric acid. Our base is our water. And then this side, this is our base, which is our conjugate base from this acid, because it was formed from this acid. And this one is going to be our conjugate acid, because it was formed after water accepted a proton from sulfuric acid. In our second reaction, we can see it's also a hydrogen sulfate reaction with water. So what happened here? For the method that hydronium ion is formed, it means water accepted a proton and formed. So water here is still a base again, but this one here is now an acid. Can you see? Why is an acid? Because it has donated a proton to water, and as water is getting a proton, water now it is now let me I just want to remove all so that I can, so that I can go back. Good. Now I want you to see that H2SO4, it is now becoming SO4. I said previously, when you look at the acid and its conjugate base, you must look at the number of hydrogens. The one with more hydrogen is an acid. The one with less hydrogen is its conjugate base. So HSO4 minus and SO4 2 minus, the difference is 1 hydrogen. So this one here is an acid and this one is a base. Here, this one was a base and this one was an acid. So in both of the reactions, you can see that water acted as our base because it was always accepting a proton from each acid. Now, the first question says, define an acid in terms of Lorentz theory, and it is 2 marks. You cannot afford to lose these 2 marks because it's an easy mark that you can get immediately when you can be able to realize what are we saying in terms of the definitions of Lorentz and Arrhenius. So it's not going to be always Lorentz. Sometimes it can also be Arrhenius. And it's not going to always be in terms of an acid. Sometimes it can be a base. So what does Arrhenius or not Arrhenius, Lorentz say about an acid? Arrhenius said an acid, as we are replying to this question, an acid is a proton donor, or an acid is a substance that can donate a hydrogen ion. So it is easy just to say an acid is a proton donor. And to say how many protons will be donated by that acid will always depend on whether that acid is monoprotic or diprotic. The second question says name or formula. It is very important that when you read your questions, you check the instructions of the examiner. There are instances where an examiner will just say, write down the name. There are instances where the examiner will say, write down the formula or write down the name of formula. So you must make sure that you follow the instruction as provided to you by the examiner. So in this case, the examiner was a little bit lenient because the examiner said, write down the name or formula of a substance that acts as an ampholyte. Now, another term that we discussed previously. What is an ampholyte? We know that an ampholyte is a substance that can act as acid and base or base. So if a substance can act as an acid and can also act as a base, we say that substance is an ampholyte. And we also gave some example of ampholytes in our previous lessons, whereby we could see that a same substance can accept and the same substance can also sometimes donate a proton. So when you look at our reaction 1 and reaction 2, we said sulfuric acid is an acid and it was only an acid in reaction 1 and it never appeared in reaction 2. But when you look at reaction 2, we are having this hydrogen sulfate ion in reaction 2. Here it was a base, but in reaction 1, but in reaction 2 is now an acid. So you can see now that HSO4 minus can act as both an acid and a base. And what makes it to qualify to do that? The minus, remember, it will allow it to gain a proton, and a plus, H plus, will allow it to be able to also donate this proton. So it is having a dual purpose. It can act as an acid if it likes by donating a proton. It can also act as a base if it likes, like accepting the proton. So an ampholyte is a substance that can act as an acid or a base. So that is why we are saying our substance that can act as an acid or a base in our reaction 1 and 2 is HSO4 minus. The examiner said, give a reason for your answer for 2 marks. So 1 mark is for identifying the ampholyte, which is HSO4 minus. And the second reason is because it acts as an acid. You explain what is an ampholyte. It acts as an acid and base. So you can say it acts as an acid in reaction 1. It acts as a base in reaction 1 and act as an acid in reaction 2 for you to be more explicit, because it is not an acid and a base in one reaction. It is an acid in reaction 2 and it is a base in reaction 1. So I think it is proper that you explain to an examiner where does HSO4 minus act as an acid and where does HSO4 minus act as a base, so that your answer is more clearer and you get your 2 marks. The next question says, the conductivity of solution of HSO4 minus and H2SO4 are compared. Which solution have lower conductivity? Explain your answer. Remember, when we started our question today, I said one of the purpose of this lesson, we are also going to compare the conductivity of strong acids and weak acids. And the only way to compare the conductivity of strong acids and weak acids is by firstly identifying those acids and strong or weak first. So the examiner provided us with some information here that will assist us to be able to see whether the acid is a strong acid or is a weak acid. Now, our Ka values that are provided, they are already telling us. It means now, if you compare this acid, which is H2SO4, and this acid, which is SO4 minus, you can see that the Ka value of this one is greater than 1. And the Ka value of this one is less than 1. So immediately you can see that this one is a weak acid and this one is a strong acid. Therefore, in terms of conductivity, they say which solution will have lower conductivity. Therefore, the one with lower conductivity will be the one which is having a Ka value which is less than 1. Therefore, for our answer, we'll just say an acid that is having a lower conductivity between H2SO4, HSO4 minus, HSO4 minus and H2SO4 is going to be HSO4 minus. Reason you can say is because it's a weak acid and it ionizes incompletely, or you can say its Ka value is less than 1. There are many reasons that you can provide for you to explain why are you saying the HSO4 minus is having a lower conductivity or weak acids have lower conductivity. So it is very important that as you are giving the explanation for you, you identify this as 1 mark and your explanation to say it ionizes incompletely or K value is less than 1 or is a weak acid. Therefore, you are getting the 2 marks because you know exactly what is the content that you have to use to explain that specific question. I think we are. I'm having lots of questions which I'm definitely gonna try and explain. And the one that is just next to me, somebody is asking what do we use? What is the use of bromothymol blue? I think maybe it might happen that the learner was not part of the first lesson. Remember, the bromothymol blue is an indicator. It's an indicator that will assist you to see whether an acid and a base have reacted, so that you can see an endpoint whereby the color of that indicator will change. And we are going to use that bromothymol blue immediately when we know that an acid and the base that are reacting is a strong acid and a strong base. And then also we normally don't have the negative pH values because we are always calculating the pH of strong acids and strong bases that are ionizing completely. So I know that this lesson is going to be a very quick lesson because it is trying and cover many things at the same time. But make sure that as you are listening, you are just noting some of the things that you know that after this lesson, you can just go and interact with your teacher and ask them. Remember, the people that I'm interacting with them in terms of the questions that I'm talking about, we are interacting with them on our WhatsApp number, which is 064 748 8913. So you can also do the same. I normally also respond to questions even after the lesson so that we don't disturb the lesson and not reach the purpose of this today's lesson. But I will try by all means, where there are questions that I feel they need immediate answers or they need immediate response, I respond, because as you can see that if a learner doesn't understand what is a bromothymol blue, it shows that maybe there's a background that the learner doesn't have in terms of that lesson. So it would be very difficult for that specific learner to follow up the lesson. So this is one of the questions that was answered by some of the grade 12 learners, and this is an examinable question. These kind of questions, they can change in any way. But what is important is that for you, you need to understand or to have the content so that you can be able to answer any question that can be given to you by the examiners. This is the response that I was just talking about. We were saying acid, according to Lori Bronsted, if they are proton donors or they donate hydrogen ions, and then We also identified this as our ampholyte because it acted as a base in reaction 1 and acted as an acid in reaction 2. And then we also classified this as our weak acid because it's the one that was having a lower conductivity. And as it's having a lower conductivity, it will have a higher pH value, but it will have a lower reaction rate again. Lower conductivity, lower rate of reaction or lower rate of reaction rate, and higher pH as compared to strong acids. So this is very important. So it's because the small Ka value, or we can say lower concentration of ions as it ionizes incompletely. The next question says, the pH of hydrochloric acid solution is provided as 1,02 at 25 degrees Celsius. So the examiner here provided you with the pH of hydrochloric acid. Now, the question says, calculate the concentration of HCl. The first thing that the examiner, the reason why the examiner is providing you with this question, it is for the method that you already know that hydrochloric acid is a strong acid. If you don't know that hydrochloric acid is a strong acid, you will not be able to relate the ions that are produced during the ionization of hydrochloric acid with the concentration of hydrochloric acid. So, for you, as you are given or you are provided the pH, you already know that. What do I know about pH? pH is equals to negative log the concentration of H3O plus. So, as hydrochloric acid will ionize to H plus Cl minus, I already know that the concentration of this hydrochloric acid is going to be the same as the concentration of the H plus or the H2O minus. So therefore, it means now I will just find the concentration of H2O plus. Oh, I'm having the pH. Yes, I'm having the pH. So the pH, okay, let me just continue with this, of H2O plus. And then the pH is provided as 1,02, which is equal to minus log, let me just use the square brackets again because the concentration of H3O plus. So this is where now you are going to use an anti-log. So it means the concentration of H3O plus for you is going to be 10 to the exponent negative 1,02. And you are going to get the concentration of H3O plus in moles per decimeter cube. So I wanted to give you this question so that you can be able to use anti-log. And you know that in terms of the anti-log, you just take that concentration or that pH, because it's going to be pH most of the time. You take that pH, you put it with base 10, and you put a negative, and you will get the pH of that number. I think we have the solution for this one. Yes, it is there. So we have substituted the pH, and then we are looking for the concentration of the hydrogen. So for them to get this answer, they just said the concentration of H3O plus is equals to 10 to exponent minus 1,02. Try it with your calculator and you'll definitely be able to get 0,0955 mole per decimeter cubed. The next question, which are now a little bit, I normally call these questions, they are questions that now will determine whether you understand the volumetric or the stoichiometric calculations that I started by explaining before you can look at these questions. These are questions, we normally call them 7.2 because they will normally have lots of calculations with them, and you will really need to know the basics before you can be able to do these questions. The question says, this hydrochloric acid, so immediately when they say this hydrochloric acid, they are already telling you that this hydrochloric acid of the concentration of 0,09, let me just verify the answer, actually the previous one, because with 0,955 mole per decimeter cube. I think we know why we're relating this concentration of hydrogen ions with hydrochloric acid. Strong acid ionizes completely, so the concentration of hydrogen ions is the same as the concentration of the strong acid. So this acid reacts with sodium carbonate, and the formula of sodium carbonate is provided according to the reaction. Here is the reaction. The mole ratio is very important, my learners, because this is the time when now you will always consider the number of moles of the reactants that are reacting with the number of the products that are produced, in terms of how do they relate in terms of the mole ratio. So we know that we are given that 50 cubic centimeter of hydrochloric acid is added to 25 cubic centimeter of 0.075 mole per decimeter cube of sodium hydroxide. So we are given the concentration of sodium hydroxide. Already we know that this sodium hydroxide is our standard solution. Why am I saying is the standard solution? Is because its concentration is provided in this question. The question says, calculate the concentration of excess hydrochloric acid in a new solution, and it is 8 marks. Most of the time, I know you are always scared when you see 8 marks, 7 marks, 6 marks, because the first thing you'll say, hey, it means there's a lot of information that is needed. Definitely, there's a lot of information that is needed, but that information is needed in pieces. So you need to be able now to firstly analyze your question. Already the examiner is saying this acid, so it means initially you have this acid of this concentration that is going to react, and the examiner is telling you that this acid is in excess, meaning that not all what you had initially will react. So it is always easy to work with number of moles, so that you can be able to see which moles never reacted and be able to find the concentration of an acid that was in excess. Because you will always use the formula N is equals to M over M, or C is equals to N over V, so that you can find the concentration in an acid. So it means we need to find the initial number of mole of an acid before it reacted with sodium carbonate, so that we can find the number of moles that reacted with sodium carbonate, and eventually find the concentration that is in excess. So when you look at your volume, it is provided in cubic centimeters. It means you must definitely make sure that you convert it into cubic decimeters. This one here, it is also provided in cubic centimeters. You must provide it in cubic decimeters. So the first thing that you do, let's find the number of moles of an acid that we had initially. So how do we do that? The number of moles of an acid that we had initially, we know that C is equals to N over V. And then we know that the number of moles, they are going to this, the concentration is provided as 0.0955, and then we don't know the number of moles, but we know that if we divide the 50 with 1000, we're going to get something like 0.005, and then we cross multiply and we find the number of moles of the initial number of moles of an acid. I always think it is very important that you label which number of moles are you calculating. At first, this is what you had initially before it reacted with sodium hydroxide. Then after that, you are going to also find the number of moles of because immediately when they say a hydrochloric acid is excess, it means this is our limiting reactant. So the number of moles of sodium carbonate that will react with an acid are the ones that will determine the product. So those are the number of moles that are going to be used, and they will also be the number of moles that are going to determine the moles that are produced. So without wasting more time, I just want us to look at how are we going. As I said, we're gonna let me start here, because I started here. We're gonna find the initial number of moles of an acid, where we say 0.09955 multiplied by, okay, when we convert the 50 is 0.05, and then we get the initial number of moles of an acid. That is the first thing. And then these are the number of moles of sodium carbonate that will react with this acid. So these are the number of moles of our limiting reactant. Therefore, in terms of the reaction, the mole ratio HCl and Na2CO3, the mole ratio is 2:1. Therefore, if we know that the number of moles of an acid that are going to react, of sodium carbonate that are going to react with this acid is 0.001875 moles, therefore we can know that we can find that one of an acid by multiplying by 2, and we are going to find the number of moles of an acid that will be used, that will react with the sodium hydroxide. Remember, why are we using the number of moles of sodium hydroxide? We are already told that as a sulfuric acid, hydrochloric acid is an excess acid, is in excess, is our excess reactant. Therefore, we know that we cannot use our excess reactant to determine the product. We always have to find the limiting reactant number of moles, so that we know that those are the number of moles that will be used and the number of moles that will be produced in our reaction. So after that, we'll find the number of moles of an acid that are used. Initially, it started with 0,00475, and then it only used 0,0038. Therefore, it means for us to find the excess number of moles, it means it's going to be initial number of moles minus the used number of moles, which is 0,0038 moles, and then we get the number of moles of an acid that are being used. So the question was looking for the concentration that was in excess of hydrochloric acid. So we know the number of moles that are in excess. We can just go quickly to our formula. C is equal to N over V. But remember, now that acid, it is no longer in the container alone when it started at 50 cubic centimeter. It is now in an entire solution. So we are now having additive volumes. We are now in a solution whereby we have the volume of an acid and the volume of a base. So the base came with 75, if I'm not 25, yeah, it is. It came with 25 cubic centimeter, which was changed to 0,025, and an acid came with an acid came with 0,05. I think it's this one. So we're gonna add the two volumes now and get the volume inside the solution, because the two volumes are additive. So this 0,05 is the volume of an acid, is the volume of an acid plus the volume of a base. And then we're going to find the concentration of an acid which is in excess in that solution. So when you look at the mark allocation, you can see that we firstly find the number of moles of this sodium hydroxide that reacted. We also find the initial number of moles of an acid that was there before it reacted with sodium hydroxide. And we used a mole ratio to find the number of moles of an acid that was used, so that we can be able to find the number of moles of an acid that was in excess by subtracting the used from the initial, and we get the number of moles that was in excess, so that we can use the entire volume of this acid and base and get what? I think the entire volume, let me just check, the acid was having what? The acid was having, yeah, it was 50 plus 25, which give us 75 cubic centimeter, divided by 1,000, which give us how much? 0,075 cubic decimeter. So this 0,075 cubic decimeter, this one is the volume of an acid and a base combined, as they are now all inside the solution. You must always make sure that you will use the additive volume. You will add your volumes after they have reacted together, because initially they were in different volumes, but as they react, they combine, and we combine their volumes. This one quickly, as I'm going to go through it, I'm not going to do number one because it still says define an acid in terms of Lowry-Bronsted theory. Carbonated water is an aqueous solution of carbonic acid, H2CO3, which have the formula and it ionizes in two steps like the one of sulfuric acid. The question says, write down the formula of conjugate base of this carbonated acid. We know that as we are doing an acid base, conjugate acid base pair, we know that this one, S is going to dissociate in water, it's going to dissociate into two steps. So at the end, it's going to have CO3 2 minus. However, I think also if you take it from here and say HCO3 minus, you can also be provided a mark, because this is a first ionization step and this one is the second ion that will be produced during ionization. Write down the balance equation for the first step of the ionization of this. So as I said, the first step ionization is going to be H2CO3, and then it ionizes to form HCO3 minus plus H plus or H3O plus. They say first step ionization of this carbonic acid. So this is what is important. You need to know that carbonic acid reacts or ionizes to form hydrogen carbonate ion and hydrogen ion. This is the first step of the ionization of carbonic acid. The pH of carbonic acid is provided as 3,4. Calculate the concentration of hydroxide ions in a concentration. The examiner is asking about the concentration of hydroxide ion, and this is an acid that is provided. So you might sometimes wonder, why are they looking for the hydroxide ion in an acid? What you need to understand is that as water is having also hydrogen ions and hydroxide ions, also these acids are also having hydrogen ions and hydroxide ions. However, in terms of the strength of the ions and in terms of the domination, what dominates in an acid is hydrogen ions, and what dominates in a base is hydroxide ions. So there are some of the few hydroxide ions that you can find in an acid, and by using KW formula, you can be able to find the hydroxide in that specific acid. But the examiner started by providing us with the pH of an acid. So what information is the examiner definitely providing us? An examiner is assisting us to find the pH of what? Of hydroxide ions. After getting the pH of hydroxide ions, because we are going to get the pH of hydroxide ions by using the anti-log, as I said. Remember, the pH is provided to you, so it means it's going to be concentration. Let me just remove this one. Concentration of H3O plus is going to be log 10 to exponent minus 3,4. We are going to look at the answer in our previous slide, in our next slide. So what you are going to do, you are going to find the concentration of hydrogen ions in moles per decimeter cube. And then after finding this concentration, you will make sure that you have concentration of H3O plus multiplied by concentration of OH minus, which is equal to 1 times 10 to exponent minus 14. And then you are going to substitute this 10 to the exponent minus 3,4. You can even get the value, and then concentration of OH minus, and then you're going to make this one the subject by dividing by 10 to the exponent minus 14, and you're going to be able to find the concentration. We're going to look at the next slide, the exact answer. The question that I'm interested on for this one is this one, because I want us to make sure that you do it. X is a monoprotic acid. Already the examiner is telling you that X is a monoprotic acid, and they say state the meaning of the term monoprotic acid. I think by now we must all be able to define a monoprotic acid as an acid that can donate 1 proton. So we are told that acid X, which is an unknown acid, is a monoprotic acid, meaning that it can only be able to donate 1 proton. A sample of acid X is titrated with a standard sodium hydroxide solution using a suitable. So immediately when they say standard sodium solution, already they are telling us that they are going to give us the concentration of that sodium hydroxide solution. So at the end point, it is found that 25 cubic centimeter of this acid X is neutralized by 27,5 cubic centimeter of the sodium hydroxide solution of concentration 0,1 mole per decimeter cube. Calculate the concentration of an acid. So you know that when an acid X, when HX react with NaOH, so you know that what we are expecting to find a salt and water. So we know that this is gonna be, the salt is gonna be, let me just go to the next slide so that we can just try to do this. We are going to find the H plus the salt. So the salt that is X, maybe XOH. I don't know what will be the salt, the one that we are going to find. So we will see that the ratio in which the acid and the sodium hydroxide will react will be the ratio of 1:1. We can use any other monoprotic acid with sodium hydroxide. You will see that they will react with the ratio of 1:1. So with the information that is provided, let me just go quickly to this one. With the information that is provided, I wanted to just put it here. I think it's this one. It's not. So we already know the volume of an acid. We know the volume of a base. We know the concentration of a base. We don't know the concentration of an acid. So by that formula of calculating concentration or neutralization, we know that C1 V1 over C2 V2, or CAVA, let me say A, B, B, so that to say concentration of an acid, concentration of a volume of an acid, concentration of a base, volume of a base is equals to the number of moles of an acid divided by the number of moles of a base. So we have already seen that the ratio that these two will react is 1:1. So already this one will fall off because it's going to be 1/1. So it's going to be CaVa is equals to CbVp. Then we are going to convert the acids volumes in cubic decimeter cube. Even though sometimes we don't convert it, they will cancel each other. And then we are going to substitute the volume of an acid, the concentration of a base, and the volume of a base for us to find the concentration of an acid in mole per decimeter cube. So my learners, I can see that now the time is against us, is against our lesson. But what we are doing today, I was just trying to show you how can you answer questions in terms of acids and bases, and what is the important information that is needed for you to understand when you answer questions under acids and bases. There are lots of questions that are asked here, like how do we find oxonium ions when given the value of pH? I think by looking at what I was doing in terms of the explanation of calculation of the pH, I said to you, remember, you will know that you will be given the pH in that regard, and then you will find the concentration of oxonium ion because you know this formula. So in this case, you will use an antilog whereby the concentration of hydronium ions will be equals to 10 to the exponent that pH that you are provided. So let me just write this formula. I think this formula is very important for you to know so that you can be able to calculate the concentration of hydronium ion. However, most of the questions that are here, they are already explained by the different examples that we have given into this lesson. I know, my learners, this was a very quick lesson and it contains a lot of information, but make sure that as you are playing this video, you know that you can sometimes pause it so that you understand things that are being explained quickly in this lesson and understand even further. By so saying, we have come to the end of this lesson. Thank you so much for watching this lesson, and remember to always wear your mask, sanitize, and keep your social distancing. Until the next lesson is goodbye from me. Thank you so much.